In this video, you are going to learn how to determine the charge or the oxidation number of an ion or a compound. And you're also going to learn how to build an ionic compound. So definition: the charge or the oxidation state of an ion is the number of electrons lost or gained to achieve a stable octet. Octet is 8. And we'll talk more about this theory next semester, but for now, all you really need to know is that 8 electrons in that outer valence shell, the highest energy shell of any atom, makes it stable. So atoms will bond to achieve this stable octet. An ion's oxidation state is based on the atom's location on the periodic table. So for example, any atom that falls in column 1 has a +1 oxidation state, whereas any atom that falls in column 18 has a 0 oxidation state. 0 means it doesn't gain or lose any electrons. These are called our noble gases, anything in column 18, and they are very stable. You will not ever have a molecule that has a noble gas in it in this level of chemistry. Down here you see variable charges. So if your atom or your ion falls in this portion of the periodic table, that is something you need to look up their oxidation state on the periodic table. So let's do a couple examples. Hydrogen, if you look on your periodic table, we'll see it falls at the top of column 1, so its oxidation state or its charge would be +1. Neon falls in column 18, it's a noble gas, so its oxidation state is 0. Iron is abbreviated as Fe actually, and it falls right around here. So it's a transition metal and it has a variable charge. If you take a second and look at your ion chart, you will find that iron has a variable charge. It can either have a +2 or a +3 charge. And we will learn how to figure out whether it's +2 or +3 later on. Right now it's important to figure out what its charge or its oxidation state would be. Alright, next we are going to learn how to build an ionic compound. An ionic compound is the bonding of a metal ion to a non-metal ion. It's always a metal to a non-metal. And we would need to look up their charges. So you'll need to keep your periodic table out as well as your ion chart. The example we're going to do, I've typed out the example because sometimes it's helpful to be able to read it as well as to be able to hear it at the same time. And I felt this was one of those times especially. So we are going to bond lithium to oxygen. And to do that, we need to know what their charges are. So lithium falls in the first column on the periodic table, so it has a +1 charge, and oxygen falls in the -2 column, so it has a -2 oxidation state. So when you are building an ionic compound, each lithium atom is giving up 1 electron and each oxygen atom is taking 2. And when you're all said and done, they need to have given up and taken an equal number. Otherwise, you've created or destroyed electrons, which we just can't do. So to do that, we need to cancel out these charges, or essentially when you add them together with the number of each ion, it needs to add up to 0. So to do that, right now, +1 plus -2 is -1. So we are -1 in the hole, if you will. So we need to add more positive ions to get up to 0, so those charges cancel out. So if we have 2 lithium ions, each lithium ion is +1, so it would be +1 times 2. So we'd have +2 plus -2 equals 0. So that would give us a total charge of 0, and this ionic compound would now be overall neutral. Each individual ion has a charge associated with it, but when they bond together, they've exchanged an even number of electrons, which allows it to be neutral. So we would write this compound as Li2O. And that would be how you would build this compound. Notice we didn't write a 1 for oxygen. It is assumed that it is 1, and we don't have to write it down. All right, and that is it for this video.